Hey students, this is lesson 734. In this lesson, we're going to learn how to solve problems using systems of equations and either using graph or elimination or substitution. You're going to need the supplement 734. If you don't have that, you might want to print that off the website. But anyway, so what we're going to do is set up a system of equations for a problem and then use one of the methods we've learned the last few days in class to solve that. So this first problem says find the value of two numbers if their sum is 12 and their difference is 4. So let's let the two numbers just be x and y. And if their sum is 12, then that's just the equation x plus y equals 12. And it says their difference is 4. That means when you subtract them, you get 4. So let's just write x minus y equals 4. And then since we have y and the opposite of y, it makes sense to use elimination here. We can add the two equations together. So x plus x is 2x, y plus negative y is 0y. So, and then 12 plus 4 is 16. Then we can just divide by 2, and we get x equals 8. And of course, there's one more solution, so we have to figure that one out, and that would be, well, we know the two numbers add up to 12, and we know that x is 8, so we just have to figure out what number plus 8 is equal to 12, and of course, that's 4. So 8 and 4, and the last thing you should do is just check to make sure that their difference is 4, and 8 minus 4 equals 4, so we're good there. So the two numbers are 8 and 4. If you want to try a problem like that, just to see if you get it before the next time we meet in class, you can do number 2. Otherwise, I'm going to move on to number 3, which says flying to Kampala with a tailwind, the plane averaged 158 miles per hour. On the return trip, the plane only averaged 112 miles per hour while flying back into the same wind. Find the speed of the wind and the speed of the plane in still air. So we're going to choose a variable x. Now what happens when you're flying is, so whatever speed you're flying, like that, if you're flying into the wind, it'll slow you down. And it'll slow you down by whatever that wind speed is. So your airspeed is actually equal to the speed without the wind minus the speed of the wind. So kind of keep that in mind, and if you're with the wind, the opposite effect. You actually get to add that wind speed. So let's let x equal the speed of the plane without the wind, and let y equal the speed of the wind. I'm just going to write those down. Okay, so we've defined our variables. Now we need to think of an equation. It says right here that this 158 kilometers per hour, that's with a tailwind. That means the wind is pushing. So we can represent the speed of the airplane as x, the speed of the airplane, and then we're just going to add the speed of the wind to that, because you can just add the tailwind to your speed, and that's going to be your flying speed, which is 158. And then if you're against the wind, you have to subtract that from your flying speed. So that would be x minus y equals 112. That's the speed while flying into the wind. And now we can solve these. And again, in this case, it makes sense to use elimination because we have our y's are opposite each other. So let's just add the two equations together. And we get 2x equals 158 plus 112, which is 270. And then dividing by 2, we get x equals 135. And remember, 135 is the speed of the plane without the wind. So it's flying at 135 miles an hour. And the wind speed is, we can use either of these equations to figure that out. So 135 plus the wind speed should equal 158. Subtracting 135 from both sides, we get our wind is 23 miles per hour. So 103 miles per hour for our plane and 23 miles per hour for our wind. All right. Okay, the next problem we're going to do is, oh, you can try another one like that. And we'll do some of those in class just so you can practice. But number 4 here, it says that the school that Stefan goes to selling tickets to a choral performance, on the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. So we want to know the price of a senior citizen ticket and the price of a child ticket. Let's let X be the price of a senior citizen ticket and Y be the price of a child ticket. All right? And then we can write an equation. They sold 3 senior citizen tickets and 1 child ticket for $38. That would be 3x plus y is equal to 38. And then the other equation is $52 for 3 senior citizen tickets and 2 child tickets. And that would look like this. And that's 52. Okay? Now we want to think of what method we want to use to solve this system of equations. Since our coefficients on our x terms are the same, we can use elimination by subtracting. And just to make this a little bit easier, and I think it'll make more sense if we subtract the 2 equations this way, then we get positive coefficients. So 3x minus 3x is 0x, 2y minus 1y is 1y, and 52 minus 38 is 14. And so we just found out the price of a child ticket. So right there, y is equal to 14. So let's write that down here, $14 per child ticket. Okay, and then to find out the price of a senior citizen ticket, we just need to use one of these equations. We know that 3x plus 1y is equal to 38, and we just found out that 1y is $14. So let's substitute that in. Subtracting 14 from both sides, we get 3x equals 24. And then dividing by 3, we get x equals 8. So $8 for a senior citizen ticket. Okay, and the last check you want to do is just make sure that 3 times 8 plus 2 times 14 is equal to 52. And I think you'll find that that is true. All right. Let's try number 5 here. It says the sum of the digits of a certain 2-digit number is 7. Reversing its digits increases the number by 9. What is the number? So let's go ahead and define our variables here. We're going to let x be the 10th digit of this 2-digit number. We're going to let y be the 1st digit of this 2-digit number. Okay, so we've defined our variables. Now the statement here says that the sum of the digits is 7. So that means if we just add the 2 digits together, not thinking about their place value, we should get 7. So that we could think of the numbers could be like 5 and 2, or 1 and 6, something like that. They add up to 7. All right, and it says that reversing the digits increases the number by 9. Now, what they're talking about there is the actual value of the number. So I just want to write this down here. The value of the number is actually 10x plus y. That's the value of the 2-digit number, because this 10th digit, actually each one of those is valued at 10 because of its place value. So, and if we reverse the number, that's going to be 10y plus x. So these are the values. And we need to think about those when we solve this. So it says that reversing its digits increases the number by 9. Reversing the digits increases the number by 9. So the value to begin with is 10x plus y. And if we reverse those digits, so this thing here, and y plus x, they're not equal anymore. And just think about this. So let's say we started with 38 and then we change it to 83. Well, that increased the value by quite a bit by changing that. And in this case, we increased the value by 9. So this is 9 more than this. So there's our equation. Okay. And I think to solve this one, I'm going to simplify this second equation as much as I can. I think what I'll do here is, let's see, let's subtract x from both sides. Get rid of that x, so then we get 9x plus y plus 9 is equal to 10y. Let's subtract 10y from both sides. Now we have 9x minus 9y is plus 9 is equal to 0. And let's subtract 9 from both sides just to get that over there. So we now have 9x minus 9y equals negative 9. Okay, and then our other equation is x plus y equals 7. So now we have to think of a way to solve that. And I think I'm going to use substitution here. I can easily solve this for x. X is equal to 7 minus y if I just subtract y from both sides. And I'm going to substitute that in for x then in this equation. All right, so I'm going to do 9 times the quantity 7 minus y minus 9y equal to negative 9. Using the distributive property, I get 63 minus 9y minus 9y equal negative 9. That simplifies to minus 18y is equal to 9. Subtracting 63 from both sides, we get negative 18y is equal to negative 72. Dividing by negative 18, we get y is equal to 4. And we know that two numbers add up to 7, so that means x must be 3. And just checking that out, so my original number was 34. If I reverse the digits, I get 43. And the difference between these two is 9, so this is 9 more. So those are our numbers and our digits, 3 and 4. All right, we'll work on some more of these in class. I think we'll start by doing the whole problem. If you want to try something before you get back to class, go ahead and go back to number 2, see if you can do that. And on the second page, you'll see some problems similar to the first ones. All right, we'll talk about this more next time we meet.